Now, students, our new chapter is software reliability and quality management. See, reliability of a software product is a major concern for almost all users. They need a quantitative guarantee for reliability, especially for safety critical products or for embedded softwares. As we know, software does not have a physical shape, and a software is not used by a single user or a single set of users. Different users makes use of different functionalities of software, and of course different users arrives at different quantitative estimation measures for measuring the reliability of the software. So it is difficult to have a common metric to accurately measure the reliability of the software. So in this session, not so deep, but we discuss some terms related with software reliability, and also we discuss some issues associated with software quality assurance. Software quality assurance, it is the major aim of software quality assurance is to help an organization to develop high quality software products in a repeatable manner. Of course, software development is carried out in a repeatable manner, and a software development organization can be called repeatable only if the software development process is person independent. The development of any software is person independent. The overall development of a software is not carried out by a single person, and also the process of development of a software does not depend on the team members, exactly the team members. It depends upon the quality of the software, depends upon the quality process, the process of development, and it does not depend upon a person. The success of a project does not depend on a single person. So the quality of the developed software and the cost of development are important issues addressed by software quality assurance. And software reliability. The reliability of a software product essentially denotes its worthiness, trustworthiness, or dependability. The reliability of a software product can also be defined as the probability of the product working correctly over a given period of time. So, a software is always developed for the user, and it must always satisfy the user's requirements. So, a software can be said as trustworthy or dependable, or a software can be said as reliable only if satisfies all the requirements of the user, and only if the product is working correctly for a given period of time. So there is a connection between the reliability and defects in a software. As you know, when there is excess defects in a software, the software could not function correctly and the software could not be said as a reliable software. A software product having a large number of defects is of course unreliable, because it could not perform well, it could not meet with his functionalities. So if a software fails to achieve its requirements, then the software could not be said as a reliable one. So there is a connection between the reliability and number of defects in a software. So it is also very reasonable to assume that the reliability of a system improves as the number of defects in it is reduced. When the number of defects in a system, in a software is reduced, the software could be said as more reliable one. But It has been experimentally observed by analyzing the behavior of a large number of programs that 90% of the execution time of a typical program is spent in executing only 10% of the instructions in a program. While executing a program, only 10% of the instructions are executed frequently. There's 90% of the execution time is spent for executing those 10% of instructions in that program. That 10% of instructions form the most core part of a program. These 10% of instructions are frequently executed so that it forms the core of a program, the main functionalities of a program. The rest 90% of the program statements are called non-core and are on the average. They are executed averagely only for 10% of the total execution time. So for this core part of a program should be most reliable one. So when we speak about the reliability of a software, the core part of the program should be error free. There should not be any defect on the core part of the program because the most frequently executed part of instructions lies in this core part of the program. So when this core part of a program is error free, then the program or the software can be said as a most reliable one because it performs its main functionalities well, and the most frequently executed statements are highly maintainable. Then of course the software could be said as more reliable one. So it is note that removing the 60% product defects from the least used part of a system would typically result in only 3% improvement to the product reliability. So more care should be given or more effort should be spent for maintaining the defect or removing the defect from the core part of the program, or otherwise removing the defects from the other non-core part of the program result only in 3% improvement of the product reliability. So it is clear that the quantity by which the overall reliability of a program improves due to the correction of a single error depends on how frequently the instruction having the error is executed. If an error is removed from an instruction that is frequently executed, then this would show up as a large improvement to the reliability figure. On the other hand, removing errors from parts of program that are rarely used may not cause an appreciable change to the reliability of the product. So the reliability of a product can be improved by removing the defect from the core part of the program. And reliability of a product depends not only on the number of latent errors but also the exact location of the errors. So from this discussion we know the location of error is important than the number of latent errors. So apart from the reliability, this number of defects, the reliability also depends on how the product is used or on its execution profile. If the users execute only those features of the program that are correctly implemented, none of the errors will be exposed and the perceived reliability of the product will be high. If the users are making use of the product that has no fault at all, the software could be said as reliable by the user because the error or defect in that program is not at all revealed by the user. So the reliability of the software is of course a measurement, an estimation that should be done by the user himself because the user should be satisfied with the product. So it is the actual measurement should be done by the user and the user will be fully satisfied. That means the user will approve a software as a reliable one if he cannot find out any fault within that program. That means if he is working with the core functionalities or that part of the program which does not contain any error, he believes that the software is a reliable one. On the other hand, if only those functions of the software which contains errors are invoked, then a large number of failures will be observed and the reliability of the system will be very low. So always the reliability of a software depends on the number of errors and the part of the program where the error is located. The location of error is also an important criteria in estimating the reliability of a software. So the main reasons that make software reliability more difficult to measure than hardware reliability are: the reliability improvement due to fixing a single bug depends on where the bug is located in the code. As we said earlier, the location of the fault, location of the defect is important than the number of defects in the program. The number of defects in a program of course reduces the reliability, but the location of the defect depends, it estimates the reliability of the software. And the perceived reliability of a software product is observer dependent, because once a user is satisfied with the product, that means if the user is using the part of the program that is free from any defect, then the software is said to be reliable by the user. So the perceived reliability of a software product is observer dependent, or it is certified by the user. The reliability of a product keeps changing as errors are detected and fixed. As for any software, whenever a defect is detected and that defect is corrected, if the error is fixed, there is no more problem with the software and the user will be satisfied. So the reliability keeps changing. The reliability of the software keeps changing on detecting errors and fixing the errors. So the problem is solved when the errors are detected and the defects are solved, corrected. If there is no error, no more errors in the program, the reliability of the software also increases, though. So it is not a steady thing. The reliability of a product keeps changing as the errors are detected and fixed. So another term with reliability is hardware versus software reliability. We know what may be the difference between a hardware and the software. Software, as we said, it has no physical appearance and it is hard to measure the reliability of a substance or a thing that is not that does not have a physical appearance. Hardware components fail due to very different reasons. Hardware components fail mostly due to wear and tear, whereas software components fail due to bugs, only due to errors. The factor that reduces the reliability of a software is the number of defects and the location of the defects. For example, for hardware components, for example, a logic gate may stuck at 1 or 0, or a resistor might short circuit. To fix a hardware fault, one has to either replace or repair the failed part. For any hardware, for any device, electronic device or anything else which has a physical appearance, the only thing we could do to fix the error, fix the correction, is that the failed part should be replaced or repaired. But for a software product, the software product would continue to fail until the error is dragged down and either the design or the code is changed to fix the defect. For this reason, when a hardware part is repaired, its reliability would be maintained at the level that existed before the failure occurred. Whereas when a software failure is repaired, the reliability may either increase or decrease. That's what we said earlier. The reliability of a product keeps changing always for a software. But for a hardware, whenever a part is found to be defective, the part could be replaced or repaired and the hardware continues to work as if it was performed earlier before finding out any defect. But for any software, the software will continue to fail until the error is corrected. That means until the code is corrected, code or design part is corrected and this reliability will change. That means it may either increase or decrease. So a comparison of changes in failure rate over the product lifetime for a typical hardware product as well as a software product is given in the figure. As we see in the figure, the plot of change of reliability of hardware product, it appears like a bathtub. As we see in the figure, the graph for the failure rate of hardware product resembles like a bathtub. That means at first the failure rate is high for the hardware product, and in its useful life, the useful life of a hardware is stable. The failure rate in the useful life of a hardware is stable for a particular, that means for a particular period of time the hardware product is much useful. It performs well without any defect for a particular period of time, and this period of time is said to be its useful life, and after that it found to be wear out. Okay, that is the failure rate for the hardware product. It just resembles like a bathtub. That means at first in the burn-in time the failures may be high, and after replacing or repairing the defective part of a hardware, the hardware remains working in a stable manner throughout its useful life for a certain period of time, and after that it may be found out to be wear out. After a long period of time, any hardware should be replaced. So the hardware components always fail due to some wear and tear. So this graph looks like a bathtub, but when we see the software product, the failure rate for a software product, when the product is released for the first time after developing a software, when the product is released for the test for the first time after testing, during the testing phase the software may found to be more defective. That means there may be more number of defects detected during the testing phase. So at this time the failure rate is found to be high. When the product is released for the first time after testing, the product may found to be the failure rate for the product may be found to be higher, because whenever a software is delivered to the user himself must certify, or the user himself should know after using it, he should find out whether the software is performing all the functionalities or not. So depending upon the customer's point of view, the software may need some more changes in design or coding, and after that, after performing all the changes in design and coding of that software, that is done according to the point of view of the customer, then the actual lifetime of the software begins from there. The useful life of the software, here the useful life of the software products remains almost same for some period of time. So the failure rate for the software product is extremely different from that of the failure rate of a hardware product, because for its useful lifetime the hardware remains the software product remains almost same. It works almost same for some certain period of time, and then it found to be obsolete. That means after a long period, after a certain period of time, any software would be found to be difficult to use, or because it may need maintenance, it may need to adjust with operate on new platforms. So depending upon the future needs of the customer, the software may need further more maintenance. With that period of time, the period of time that is the software is used to its maximum extent is called its useful life. So in its useful life, the software can be found to be, the failure rate on a software product can be found to be almost stable. In contrast to the hardware products, the software products show the highest failure rate just after the purchase and installation. For the first time, when the product is released for the first time, it is found that the failure rate is high, and then as the system is used, more and more errors are identified and removed, and it results in a reduced failure rate. So this error removal continues at a slower pace during the useful life of the product. As the software becomes obsolete, no more error correction occurs and the failure rate remains unchanged for the software product. I think you have a basic idea about the software reliability with this session, and we shall continue with the software quality on the next session. Learn well. Thank you.